Hi and welcome to my maths class. Today we're going to discuss the theorem that states the angle between a tangent to a circle and a chord drawn from the point of contact is equal to the angle in the opposite segment. Now this theorem has a lot of vocabulary that you need to understand. Firstly, we have the word tangent. Now we've discussed tangent before. It is a line that touches the circle at one point. So it's only touching at B. Then it tells you the angle is between a tangent to a circle and a chord drawn from the point of contact. Now what do they mean? They mean this chord is touching B also. So the chord they're referring to when they say point of contact means that this chord, you know, a chord is a line that is drawn from one side of the circle to the other. It doesn't need to cross the center, but it is simply drawn from one side to another. Then it is touching the tangent. Now in this drawing we have two chords. If you look, DB is also a chord that is touching point B and the tangent. So they could be referring to any of these ones. Then it says it's equal to the angle in the opposite segment. What you must remember is that a segment, if I give you a circle and I draw a line, then we have discussed the segment. From this arc, if you take this arc here that is created by the line that you've drawn, then this would be the one segment and this would be the other segment. So sometimes depending on the size they'll call it a minor arc and a major arc. But what is important is if I am working with this segment, then the opposite segment would be this side. So a line that's cutting the circle, you'd have two segments, and if I am working on the right hand side, then the left hand side is the opposite segment. Right, now if you look at this drawing that we are working with, and I am working with the segment BC. Now why am I choosing BC? Because I had chosen the line BC to work with, I'm going to choose to work with the arc BC. If you chose that line segment, then the arc you're referring to is BC. Now, the segment that's created by BC and the arc that's created, this part is the segment that we have. So what would refer to the opposite segment? The opposite segment would refer to the entire thing here. This is the opposite segment. Can you see? The entire thing is the opposite segment. But the entire thing is not creating an angle. What is creating an angle that is also running from BC? BC is this line. And it's creating an angle in the opposite segment. If you take the point B and you take point C, it is creating an angle in the opposite segment. Look. That's the angle it's creating. So even though the entire place here is the opposite segment, the angle that is created with line BC is D1. Now that you understand the vocabulary, so when I say the angle between a tangent to a circle and a chord, so I'm referring to the tangent and the chord, then the angle I'm talking about is B1. And it is equal to the angle in the opposite segment. Then the angle I'm talking about is D1. Now you must understand the language before you can use the theorem. And to use the theorem in this specific one, we have to prove the theorem. Now let's start with our proof. Okay, first we're going to discuss with what was given. What have they given us already? They gave us a center 0. Okay, and then they told us BC is a chord and BD is a chord. So we've got BC and we've got BD. Now by now you should have realized that two letters imply a line. So I'm referring to line BC and I'm referring to line BD. Right, what do you want to prove? We want to show them that B1 is going to equal to D1. That is what we want at the end. We want to show them, listen, B1 is equal to D1. Let us construct now. Remember, you can only construct in proofs. You cannot construct in riders, right? A rider is a question that they ask you and it has a few circles or few different points, but a theorem is very specific. It would be something that you've seen already and it looks exactly as it always looked. Right, so we're going to construct a line. We're going to call it POB. Then we're going to join PC. So now we've constructed line PC. POB is a diameter. Then we know angle C. So we're going to say angle PCB is equal to 90 degrees. Why? Angles in a semicircle or angle at center is twice angle at circumference. So you can say angles in a semicircle, or you could say angles in the center is 2 times angle at circumference. So if this is 180 degrees, then angle PCB is 90 degrees. Now let's mark this B2 and P1. Now P1 plus B2 is going to equal to 90 degrees. The reason, it's the remaining angles of a triangle. Now you'll see this symbol that goes like this refers to angle. So it's the remaining angles of a triangle. Then we have that P1 is equal to D1, angles in the same segment. What you usually refer to as the butterfly or the bow tie, you can see angles in the same segment. Now we also have that B1 plus B2 is equal to 90 degrees. Tan perpendicular to radius. Remember, this is a tangent and the line is coming from the center to the tangent, so it's 90 degrees. Now if you take those two equations, what do you notice? That P1 is equal to B1 because we have the 90, we have the B2. So we have that P1 is equal to B1. But P1 is equal to D1, which you've proven. Therefore, we have that B1 is equal to D1, which is exactly what you wanted to prove. Thank you for watching.